Morning. Today you're going to be learning about different types of nuclear radiation and the properties that different types of nuclear radiation have. But before we do that, I wanted to show you a quick demonstration of one of the ways scientists realise that there are different types of nuclear radiation. Let's have a look at the equipment. Here we have a detector, which is similar to the detector that Geiger and Marsden used in their famous experiment with Rutherford. This tube is in fact named after Geiger. It's called a Geiger-Müller tube. It's a particular type of detector. It is connected to a counter. So rather than having some PhD students counting little sparks of light, we've got a machine that is doing the counting for us. And you can see that it is counting quite happily at the moment, although fairly slowly. This is because we're surrounded by background radiation. We've also got the counter attached to a speaker, so every time you hear a click, that tells us that a particle of nuclear radiation has entered the detector. Okay. First, we'll have a look at a source. This is a very, very small sample of a source of nuclear radiation, an element that gives off nuclear radiation. The thing I'm holding is the container, and inside the container is the source itself. Now if I hold the source of nuclear radiation up to the Geiger-Müller tube, you can see that the counter starts counting very, very quickly indeed. Hundreds and hundreds of nuclear particles are entering that tube and they're being counted. And if I move it away, we can see the counting stops. Now a couple of things about this particular type of nuclear radiation. You'll notice that if I move the source just a short distance away, the counting slows right back down to normal, just the background nuclear radiation. So whatever this nuclear radiation is, it cannot penetrate very far. It cannot get through more than a few centimetres of air. And another experiment I can show you, you'll notice that even if I put a piece of paper in between the source and the detector, most of the particles are stopped. So those particles cannot penetrate a piece of paper either. If I move the paper away, so whatever this nuclear radiation is, we know that it is not very penetrating. It can't get through a few centimetres of air, and it cannot penetrate a piece of paper. I shall put this one back and get another one. Okay, second source of radiation. Looks very similar because it's in a very similar container. The source is on the inside, and again if I hold it up to the detector, you can see the detector starts counting hundreds and hundreds, thousands even, of particles that are entering it. But this one is slightly different. If I move it further away, actually it's still counting fairly quickly. Not as quickly, but fairly quickly. So this type of nuclear radiation seems to be behaving slightly differently. It can penetrate a few centimetres of air. More importantly, this one can penetrate a piece of paper really quite easily. So scientists realise that there must be at least two different types of nuclear radiation because they behave in different ways. One is not very penetrating at all. It can't get through a piece of paper. It can't get through a few centimetres of air. But the other type was more penetrating and it could get through a few centimetres of air.